Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. Now, in this particular video, we are focusing on May-June 2024, variant 31. So now let's look at this first question. The first question is about binomial expansion. And it's a pretty simple, basic question of binomial expansion, and it's worth 4 marks. So now remember, the number of marks should equal the number of minutes when you are trying out something in the non-examination mode, and that is the maximum. So now over here, it's saying expand 3 plus x into 1 minus 2x raised to power of half in ascending powers of x up to and including the term in x square. So 1 minus 2x raised to power of half, you apply the formula, that is 1 nb power 1 over 1 factorial. This is nb power 2 over 2 factorial. And also don't forget n minus 1. This thing over here is b. This thing over here is n. That is how you write it. Take care of the positive negative sign. And this is what you get. And then it says multiply it selectively with 3 plus x. So now let's look at the shading. You take this 3, you multiply, you take this 3, you multiply with 1, you multiply with negative x, you multiply with negative x square over 2. So these are the 3 terms that you are getting. And what is the next thing? The next thing is positive x. It's multiplying with 1, multiplying with negative x. I multiplied it over here, but as such, I don't need this particular term. Why? Because they are saying expand all the way up till x squared. So these are the first 3 terms that I'm getting, and it's worth 4 marks. So the first question is done and dusted. Now for 4 minutes, try out question number 2. Let me pause the recording. So now people, let's look at this question, which is question number 2. It says solve the equation ln x minus 5 is equals to 7 minus ln x. The very first thing that I'm doing is that I'm bringing all the ln terms to one side, constant on the other. Then I'm applying the rule of ln. Ln, there is a positive sign. Therefore, x minus 5 into x, this equals to 7. Then I'm changing it into the index form. X minus 5, this whole thing is e raised to power of 7. And then x square minus 5x minus e raised to power of 7 equals to 0. Is this all good, all clear? Now, first of all, what we need to do is that definitely we know that it won't factorize. So compare it with ax square plus bx plus c equals to 0. A is 1, b is negative 5, c is e raised to power of 7 with a negative sign. So therefore, first evaluate b square minus 4ac, which is negative 5 whole square minus 4 into 1 into negative e raised to power of 7. Now take out your calculator as well as I'll take out mine. So first of all, what I need is that shift ln 1. So I have the e button, raised to power of 7. So this is not e to the power 0. Hold for a second. This is e raised to power of 7. That is coming out to be 1096.633. So this is 25. And let me multiply it with 4. That is 4386.53. Let me add 25 to it. Let me take out the square root. After the square root, this is coming out to be 66.42, correct to 4SF. So therefore, x is equals to minus b plus minus square root b square minus 4ac, the whole thing divided by 2a. So therefore, this is minus minus 5 plus minus after the square root, that is 66.42 divided by 2 times 1. So this is 5 plus minus 66.42 over 2. Now there are 2 options. The first option, either that is 5 plus 66.42 divided by 2. The other option is 5 minus 66.42 divided by 2. Now, which one will we reject? We will reject the negative value because x minus 5 will be negative. You cannot take ln of a negative number. So therefore, reject this one, accept the other one. So the final answer, correct to, they're asking to give to two decimal places. So the final answer over here, that is coming out to be 35.71, correct to 2 dp. That is how the working is done. So that is question number two. So now people, let's look at the working for this particular question, which is question number 3. It says the variables x and y satisfy this equation where a and b are constants. The graph of y against ln x is a line passing through these 2 points. These are the 2 points given. I have labeled them as a and b. As shown in the diagram, find the value of a and b, give value, each value correct to nearest integer. So now officially we give the answer to 3SF and therefore we work in 4SF. But over here in this question, they're asking an integer. So first just work in 4SF or 3SF and then at the very end, round it off. First part is about coordinate geometry. There is point A, there is point B, there is the gradient change in y over change in x. Now I'm working in 4SF. Plug this value in place of gradient. Plug any point. I plugged in the first point. I evaluated C, again 4SF. And then the linear law part start. A raised to power of y is bx. Take natural log of both sides. Ln a raised to power of y is ln of bx. This y comes down. So this y comes down and multiplies. And this bx is multiplying. So there is a positive sign over here. Make y the subject. So y is ln b over ln a. Y is ln x over ln a. The constant attached with the variable, which is x in this case, which is ln x in this case, is 1 over ln a. That's the gradient. And the constant all alone on the right-hand side, that is c. So first, let's play with this. So if I play with this, 1 over ln a is equals to m. That's the value of m. You use the rules of indices. You find a as 7.0146. Similarly, the second equation for y-intercept, ln b over ln a is equals to c. Over here, what I did is that I plugged in ln a over here in place of ln a. And then I made ln b the subject, and I find the value of b. That is right over here. So that is b. Since they are asking us to give the answer to the nearest integer, so therefore the value of a is 7 and the value of b is 5. That's how this question is done. Also, let's look at question number 4. Now, question number 4 says the complex number u is given by such and such. It's in the third quadrant because x is negative, y is negative. Always make a diagram. I have labeled it. I first found the basic angle. What exactly are they asking? They are asking the answer in the trigonometric form. Everything else is a standard thing. They always ask it, and they are asking for the exact values. And in part B, another complex number is introduced. It's already in the trig form. Now they are asking in the exponential form. So there are 3 formats. The algebraic, that means the Cartesian form, the trig form, and the shortcut of trig form is the exponential form. So what you do over here is that you find the value of alpha, which is the basic angle. For basic angle, ignore the negative sign. This is change in y over change in x. It's an exact value, which is pi over 3. Since it's in the third quadrant, what is the rule? You go clockwise, and this is pi minus the basic angle, but with overall with a negative sign. So I hope you remember what I taught in my regular classes. Let me draw it over here. For complex number, remember this diagram. In the first quadrant, theta equals to alpha. In the fourth quadrant, theta is negative alpha. In the second quadrant, theta is pi minus alpha. In the third quadrant, theta is alpha minus pi. This is only for complex number because we are going from 0 till pi and 0 till negative pi. So now we get this. We also find the magnitude, which comes out to be 2, and then we write it in the trigonometric form, the polar form. Next part. The complex number v is given by such and such. So what's the magnitude of v? That is 5. What is the argument of v? That is pi by 6. Now, what are they asking? They are asking express the complex number v over u. So v over u, the overall magnitude is the individual magnitudes divided together.
And what is the magnitude? What is the argument of v over u? That is subtraction. This is related to rules of logs. So argument v minus argument of u, minus minus cancel, you get 5 pi by 6. Therefore, I have introduced a new variable. Let w be written as v over u. So first of all, I wrote in the polar form, and then I converted into the exponential form. So first the polar or the trig form, and then based upon that, I convert it into the exponential form. So that's how this question is done. Now try out question number 5. So now let's look at this particular question, which is question number 5. It says the equation of a curve is this. X line lies between 0 and 2 pi inclusive. Find dy by dx. Find the x coordinates of the stationary points on the curve for 7 marks. This is related with quotient rule of differentiation. So let me write the quotient rule over here. If y is equals to u over v, therefore dy by dx, that is v u prime minus u v prime over v square. So over here, the numerator, that is u. So the numerator is u, and the denominator is v. Keep that in mind. Order makes a difference. So now over here, this is u, this is u prime, this is v prime. Cos square x is written as cos x the whole thing square, and then you differentiate using chain rule. So now over here, this is u, and this is v prime. Sorry, this is v. First of all, let me write v over here because it starts this way. And over here, this is u prime. There is a negative sign in the middle, and this is u, and this is v prime. And instead of writing one on top of the other, which causes trouble, I have written v square on the side. So this is v square on the side over here. Now, the very first thing that you should do in P3 is that take common wherever possible. So I've taken cos common. I have written e raised to power of sin x common. So this cos x is common and e raised to power of sin x is common. Let me just highlight it a bit. So that is this thing. Cos x common. Hold for a second. That is for the next part. Let me remove it. So first of all, this is cos x, that's common. And this is e raised to power of sin x, that's common. And what is left on the inside? On the inside, we are left with cos square x, that's over here. And we are left with this negative, negative becomes positive. This 2 remains, sin x remains. That's all on the inside. Divided by cos raised to power of 4x. Now also remember, you have taken this thing common out. There is cos power 4x over here. Therefore, what is left at the denominator? Cos cube x. And now, what is now left? This thing is dy by dx, make it equal to 0. Denominators disappears. This whole thing equal to 0. Therefore, e raised to power of sin x is 0. Yeah, cos square x plus 2 sin x is equals to 0. E raised to any power will always give you no solution. Discard that. Over here, what we are doing is that we are doing using the identity cos square x is 1 minus sin square x. And then you get this quadratic equation. This is P3. So most of the equations won't factorize. In P1, most of the equations do factorize. First of all, I have a habit of calculating b square minus 4ac. Then I plug in the formula. The equation is in terms of sin x. So whatever you are getting, that's value of sin x. One value is 1 plus root 2, which is greater than 1. So that is why we are discarding it. The other value is 1 minus root 2, which is a decimal value between 0 and 1. And then we apply the 4-step method. What is the 4-step method? The first is about the quadrant. It's about third and fourth quadrant. The next one is about the basic angle. Let alpha be the basic angle. We always calculate it with a positive ratio. We find the value of alpha. We are working in radians. The examiner has made a small mistake of writing a degree symbol with the radian thing. It's in radians, not in degrees. The third thing that is about this modification of range, there is no modification because it's still x and it lies between 0 and 2 pi. So make a habit of writing it down. And then the final answer it's in the third quadrant, that is pi plus the basic angle. In the fourth quadrant, it's 2 pi minus the basic angle. These are the values correct to 4SF, so that the final answer is given to 3SF. So that is how this question is done. Now let's try out question number 6. So now let's look at this question. This question says, by sketching a suitable pair of graphs, show that the equation cosec half x is e raised to power of x minus 3 has exactly one root denoted by alpha in this particular interval. First of all, let's focus on cosec half x. Cosec is the reciprocal of sine. Since it's half x, it's reciprocal of sine half x. What is the rule for sine? Whatever is the coefficient of x, that many cycles in 360 degrees. So since the coefficient is half cycle in 360, but you are drawing till 180. So 360, half of 360 is 180, half of half is 1/4. So you would draw 1/4 of a cycle. This and this, that's one cycle. Only this, it's half cycle. And just this much is 1/4 of a cycle. So make sure that you mark the asymptote over here. This is like this. And make sure you mark this with an empty circle. Actually, no, my bad. This is not an empty circle. This one is, yes, this is empty because this is not inclusive. My bad. So now over here, the purple one, that's e raised to power of x minus 3. Basically, it's e raised to power of x. The asymptote was y is equals to 0. It shifted to y is equals to -3. The y-intercept was 1. It's shifted 3 units down. So 1 becomes -2. So there is a negative over here. And there is one point of intersection. That means graphically, we have proven there is one point of intersection. Now it says verify by calculation that the root lies between such and such, which is 1 and 2. For that, make sure all the terms on one side. Right hand side should be 0. So basically, I should write an extra step over here. Cosec half x plus 3 minus ex equals to 0. And then this is written as fx. Make sure calculator is in the radian mode. Plug in the value of 1. This is coming out to be negative. Plug in the value of 2. This is coming out to be positive. Since there is a change of sign between f1 and f2, therefore root lies between 1 and 2. And then the third part. Show that if a sequence of values given by the iterative formula converges, then it converges to alpha. What it means is this. Either you prove that the equation becomes the iterative formula, or you prove that the iterative formula is the same thing as the equation. So what I have done is that I have taken the equation and I'm equating it to the iterative formula. This is the equation. Cosec half x is ex minus 3. Take this 3 on the other side. Now let me write in words over here. Take natural log ln of both sides. And hence the iterative formula is created. X all alone on one side has the subscript n plus 1 because we write it in this form. Xn plus 1 is a function of xn. And whatever x are there on the right hand side or on the other side, that has the subscript n in it. Now let's look at part D. Use the iterative formula. Initial value, they have given it themselves because they are not in the mood to take any risk. To give alpha correct to 2 dp, give the result of each iteration to 4 dp. This is the initial value. First plugin is shown. This is working in 4 dp. Then this becomes the input. This is the output. Then this becomes the input. This is the output. And I think I just did one extra step. Otherwise, if I can stop my working over here, 1.497 is becoming 1.50. So this is becoming 1.50. This is also becoming 1.50. So let me just remove this thing over here. So I think the working is good up till here. As long as you getting two answers which are consecutive, and rounding off to the level of accuracy that they have asked. If it's the same, you stop your working over there. Now it says state the minimum number of calculated iterations needed with this initial value to determine alpha correct to 2 decimal places. So what are the steps? That is the initial. So 1 step, 2 step, and I think this is the 3rd step. This is the 4th step. So let me write over here. I think I missed out a subscript or something. So x0 is the initial one. That is x1. And then let me write over here. This is x2. So this is x2. This is x3. My bad. For a second. This is plugging in x1. I'm getting x2. Plugging in x2. I'm getting x3. Plugging in x3. I'm getting x4. So basically, I have done this question in 4 steps. So now this thing is done. There is a blank page. And now let's start with question number 7, a loci question related with complex number. So now let's look at this question. Nowadays, they give questions of complex numbers like as 2 separate questions, one related with the algebra, the trig, and so on, and the other one separately for loci. So now in this question, it says on a single diagram, sketch the loci given by the equations. This is a circle, modulus on one side, constant on the other. And then over here, these are 2 modulus equating to one another. So what is this? This is a perpendicular bisector. Now, the very first thing that I did over here is that I mentioned what each thing represents. This is the information for perpendicular bisector. This is the information for the circle. First, the adjustment, there should be a minus common out. Whatever is on the inside, that is the center. This constant is the radius. Over here, again, a minus common out, again, a minus common out. It's a perpendicular bisector of the line joining these 2 points. I have labeled one of them as A, the other one as B. Since I'm interested in the equation of perpendicular bisector, so I found the midpoint, I found the gradient, negative reciprocal, that's the gradient of the perpendicular bisector. So that gradient of the perpendicular bisector is drawn. And let me label over here. I chose this thing, m is equals to midpoint m 0, 1, gradient 1, equation of a line y is equals to x plus 1. So that's how this is drawn. So now this is the perpendicular bisector and this circle is this one. Now it says, hence find the least value of z minus w modulus. It doesn't make a difference whether they ask for z minus w modulus or w minus z modulus. It means the shortest distance between the 2 loci. What it means is that shortest distance between 2 loci. And from the topical book, we did 2 questions just like that. So now give your answer in an exact form. Now the trick over here was which point to use. Now focus over here, 3, -2. Focus over here, 3, -2. When you are drawing this perpendicular bisector, the center of the circle is one of the points for this perpendicular bisector. That means this perpendicular bisector, for shortest distance, if I draw a perpendicular from here, it will pass through this midpoint. That was the trick. You cannot choose any random thing. You have to choose this thing. So now over here, since perpendicular bisector is for these 2 points, and 3, -2 is also the center of the circle, find the distance from 0, 1, which is the midpoint, all the way till the center. So now 0, 1, 3 - 2, this distance is coming out to be √18. I have written in a simplified form. The least value would be this distance minus the radius. So the least distance would be this. Let me label this point as, let's call it T. So this is mt. The least value is this distance mt. How can you find mt? Find this distance and subtract the radius. That's how this question is done. Now try out question number 8. So now people, let's look at this question, which is question number 8. It says use the substitution u is 1 minus sine x to find the exact value of this integral. Give your answer in the third form, where a and b are rational numbers to be determined for 7 mark. Now, when we talk about substitution technique for integration, look at the numerator, look at the denominator, look at dx, and look at the limits. These are 4 things that you need to change. Always start with the basics. That is about differentiation. U is 1 minus sine x, therefore du is negative cos x dx. That means if I am able to find cosine x and dx somewhere, I will replace it with negative and du. I'll transfer the negative du to the other side. That's the first thing. Then look at the denominator, 1 minus sine x, the whole thing square root. Now keep in mind, u is 1 minus sine x, correct? So over here, 1 minus sine x, the whole thing square root is basically square root of u. That is the second thing. Now comes the third thing. The numerator has sine 2x. What is sine 2x? 2 sine x cosine x. Now remember that sine x is 1 minus u, because u is 1 minus sine x. Therefore, sine x is 1 minus u. And cosine x dx is minus du. So cosine x is over there. Cosine x with the dx, because you'll also be replacing this thing over here. You will be replacing dx with du. So cosine x dx is negative du. Now everything is getting into one place. So therefore this 2 is this 2. This sine x is 1 minus u. This cosine x is minus du. Now change everything over here. So this is 2. 1 minus u, negative du, that is sine 2x. 1 minus sine x, square root is square root of u. And what is the only thing that's left? That is the limits. When u is 1 minus sine x, when x is pi, u is 1 minus sine of pi is 0, 1 minus 0 is 1. In the mark scheme, it's mistakenly written as 0. It's not 0, it's 1. Upper limit, x minus 3 over 2 pi, that's 1 minus sine of 3 over 2 pi. Sine of 270 degrees is negative 1. 1 minus minus 1, that comes out to be 2. So now let me put things over here. First, simplify this thing according to indices. Integrate each term, simplify again. I multiplied both terms by 2. So this is 4 over 3. U raised to power of 3 over 2, I have written as u square root of u. And this is u raised to power of half is root u. First, plug in the upper limit. So let me focus on the upper limit. That is 2. So 2 goes over here, 2 goes over here, 2 goes over here. And then plug in the lower limit. So 1 goes over here, 1 goes over here, 1 goes over here. And then you would simplify. So when you simplify, you have these things together like this. And the root terms are together. And then these terms, the constants, the normal constants are over there. Simplify. And this is the answer that you are getting. They are asking us to write the answer in the form a plus b root 2. So this constant is a and b is negative 4/3 root 2. That is the answer. That's how this question is done. Yes, I'll just minimize it. I'll also share the image with you people. Now let's discuss question number 10 first. It says y d2x is equals to tangent of y. This I have written later. Why have I written it? You'll soon know. Show that dy by dx is 2 over 1 plus 4x squared. What you do is that since dy by dx is like this and y is not the subject, so you should differentiate both sides with respect to x. That is how we got started with the differentiation of tan inverse. This is similar thing to that. When we differentiate 2x, we get 2. When we differentiate tangent, we get 6 square y. If I make dy by dx the subject, that is 2 over 6 square y. We know this identity, 1 plus tan square is 6 square, whatever the variable you want to choose. So therefore, 6 square y is 1 plus tan square y. All good? But it's not over yet because we want it completely in terms of x. So how is 2x and tangent y related? tangent y is 2x. Therefore, tan square y is 2x, the whole thing square, which is 4x square. Therefore, dy by dx is 2 over 1 plus 4x square. Very involved question. Implicit, writing sec square, changing it into tangent, changing it into the variable x. Three things were there. Now it says, hence, that means you have to use the above result. Hence, find the exact value of this integral, which is x multiplying with the trig function. Now, the very first thing that you realize that this is integration by parts. But the question is, what should be u? What should be this thing? Now, usually when we apply this process, LATE, if we talk about algebra and trig, what should be u? Algebra. But over here, the tables are turned. Why? Because the question is designed that way. They have tan inverse 2x. Now, do you see anything on this page? Where is tan inverse 2x? The very first line. On top of that, if 2x is tangent y, what is y equals to? Tan inverse 2x. That means we know the derivative of this. So therefore, this time we will take u to be the trig function. That was out of the box. So now you would write u to be the trig function. You already know the derivative. That's what the question started with. dv is equals to x dx. V is x square over 2. Apply the formula u v minus integral v du. So this is u, this is v, this is minus, this is integral, this is v, this is du. It's not over yet. When you multiply it out, now the difficult part starts. This is u v minus integral v du. Now, how would you solve this? Now, the first step, that is long division. Why? Because as such, you cannot apply tan inverse. As such, you cannot apply partial fraction. You first have to simplify it. So this is the first step. X square is on the inside, 4x square plus 1 is on the outside. When we divide, I get a 1/4. 1/4 into 4x square, x square, 1/4 into 1, which is 1. Change the sign and add, you get a remainder. So this is remainder. This is quotient. This is divisor. Quotient plus remainder over divisor. That is what I have written over here. Now another part starts. Now this small adjustment needs to be made. What is that small adjustment? When we integrate something of this format, 1 over a square plus x square. What is the coefficient of x square? 1. Once you have determined it to be 1, then you write 1 over a tan inverse x over a plus a constant of integration. Of course, a limit would be there, so there won't be any constant. When I have 4x square plus 1, I should take 4 common out. This is x square plus 1/4. Let me write one more step. This is 4. This is x square plus half square. Now you are in a position to integrate this. Now let's look at the working. This 1/4, the top 1/4 was part of it. This 4 is the common one. 1/4 divided by 4, that will make it 1 over 16. This is 1 plus 1/4 x square. This is 1 plus half x whole square. Now you apply tan inverse. So this is 1 over a tan inverse x over, this is not 1/4, I changed it later. So this is 1 over 2. And then this is what you are getting. So now the integration part is done. Now let's plug in the limits. So now the limit will go over here, over here, over here, and over here. There are 4 places. Over here, this is x, it will be squared. Over here, you will multiply with 2 first. So 2 into root 3 over 2, that leaves root 3. I'm first talking about the upper limit. Root 3 over 2 whole square will be 3 over 4. Keep that in mind. Over here, it will remain as it is. Over here, this also becomes root 3. So look at the working over here, which is already done for you. Root 3 over 2 whole square, root 3 after multiplication by 2. This is root 3 over 2. This is root 3. Now let's plug in half. If I plug in half over here, half square is 1/4. Over here, it's simply half. Over here, it's 2 times half. Over here, it's 2 times half. So this is 1, this is 1. So let me slowly move it up over here. That is half square, that is 1, that is 1, that is half. And now look at everything in one shot. That is over here, this is 3 over 8 because root 3 square is 3. This is 2 square is 4. 4 into 2 is 8. Now in this integration question, these are the nitty-gritties that you have to take care of. Tan inverse of root 3 is pi by 3. Tan inverse of root 3 is pi by 3. 1 over 8 remain as it is. 4 into 2 is 8. Root 3 remains as it is. So now what is happening? I have 1, 2, 3 terms over here. Double check. 1, 2, 3 terms over here. Over here, the bluish terms for the lower limit. Half square is 1/4. 1/4 into 2, 1 over 8. Tan inverse of 1 is pi by 4. Tan inverse of 1 is pi by 4. 1 over 8 as it is. 1/4 into 1 over 2 is 1 over 8. All good, all clear? Now focus on these ones. Now take this one, and that is when you add it, 3 plus 1 is 4 because the denominator is 8, that is 4 over 8. Over here, this is 1 over 8, this is 1 over 8. When you add it up, what happens? That is this 2 over 8, and make sure that you take care of this negative sign. This negative sign is over here. Now what is left? This thing is left, negative root 3 over 8. This negative and this negative makes it positive, positive 1 over 8. That is over here, this step, this step, this step, this step, and over here I've just taken 1 over 8 common out. So that is the simple working, that's up till here. Now what about the working over here? Over here I have taken 1 over 8 common out. This is 4 pi, this is 2 pi. It has a denominator of 3, it has a denominator of 4. Knowledge of basic maths is assumed. Take LCM, simplify, you get this thing. And that is one tough question, not just because the integration was tough, definitely that was so true. So this is like 3 marks, 7 mark, 10 mark, and it's a 10 mark question. I think it should be worth 15 marks. So that was one tough question. Now I think I've skipped 1 or 2 questions. Let me first do 11 and then I'll go to, I think, the vector question which I skipped. So now let me highlight this thing. First thing first, in a field, there are how many plants? 300 plants of a certain variety. So let me just make sure that it's all good. There are 300 plants of a certain species, all of which can be infected by a particular disease. At time t, after the first plant is infected, there are X infected plant. The rate of change of X is proportional to the product of the number of plants infected and the number that are not yet infected. So if X are infected, there are altogether 300. So 300 minus X is not yet infected. The variable X and T are treated as continuous, and it is given that this is the information that is given over here, which is dx by dt is 0.2 and X is 1 and T is 0. Show that X and T satisfy this differential equation, and that's the differential equation over here. Now first of all, what's the first thing? Dx by dt, rate of change of X with respect to time, it's proportional to X, 300 minus X. In the proportionality, add the equal sign, plug in the values over here, evaluate k, work in integers because we are dealing with integers, not with fractions. Now k is over here, 1 over 1495, cross multiply. This is exactly what's written over here, so that's for 2 marks. Use partial fractions, solve the differential equation, obtain an expression for t in terms of a single log involving x. 1 over x 300 minus x dx is 1 over 1495 dt. So I took this format because I want partial fraction to be clean. For it to be clean, I want just a 1 at the top. So 1 over x 300 minus x, that's a over x, b over 300 minus x. This is a denominator with linear factors. And then we do the needful, we find the value of a, we find the value of b. 1 over 300, that is a, that is b, taken common out. And this is 1 over x, 1 over 300 minus x, 1 over 1495 dt. So if there is 1, after integration, 1 becomes t, t gets multiplied with this 300 is transferred to the other side. So let me highlight this thing.
So now this 300 is transferred over here. This 1495 was already there. After simplification, this is what you are getting, 600 over 299. Now, how do you integrate this? This is 1 over 1 ln x. This is 1 over negative 1 ln 300 minus x. This is basic integration. Constant is on the side. Now, a lot of people, they are very finicky. Why is the constant on this side? Why is the constant not on the other side? Because we are making t the subject. Doesn't make a difference at all. Have some confidence, have some nerves. It doesn't make a difference. Evaluate the constant, plug in the values, evaluate constant. Now, if you want to make the subject, transfer the constant to the other side. What difference will it make? So it's ln of 1 over 299. So ln x over 300 minus x minus ln 1 over 299 is this thing. Now, which rule of logarithms have I used over here? Let me write it down. So log x base a, yeah, let me write it like this. Log xy base a, that is log x base a minus log y base a. So basically, I have gone in this direction. So now there are two terms over here. The first term is x over 300 minus x. The next term is 1 over 299. There is a minus over here. Minus becomes division, and you know exactly what to do. And then in the end, we make t the subject. So when we make t the subject, this is what we are getting. And that's a straightforward question of differential equation. Much simpler than that scary integration thing. So 2 plus 9 is 11. I think this is much easier. So expect something wild in the middle. If you get across something like this, just skip it and then come back to it later. The last question of this paper is this one. The equation of two straight lines are such and such. That is line 1, that is line 2. Where a is a constant. And then it says the lines are perpendicular. Now keep in mind, this is like the first paragraph. So this first para, it's applicable for the whole question. That the lines are perpendicular, the equations are such and such, a is a constant. This is true for everything. First thing, show that a is equals to 4. So what is the knowledge over here? The knowledge that we use is this thing. If two lines are perpendicular, then the dot product of the direction vector should be 0. So therefore, we choose this one. That is this thing. Let me just use the color. Hold for a second. This is the first direction vector, 2, minus 1 and a. Just the coefficients. And this is the second direction vector. That is 3, minus 2 and 2. We do the dot product. We find the value of a. A comes out to be negative 4. Now for the next part, just use this value of a unless they change it. No, they are not changing it. It says the lines also intersect. That's additional information. Find the position vector of the point of intersection. So expand line 1. That is this thing, expand it. So what you do is that you take the 1 from here, you take 2 lambda from here. So this is 1 plus 2 lambda. Similarly, 1 plus 2 lambda, negative 2, negative lambda, 3 plus 4 lambda. This is negative 1, negative 3 lambda, 3 mu, minus 1, minus 2 mu, minus 1, minus 2 mu. You don't have to prove that they intersect, but if you do, it's not a bad thing. Let me pull the blue equation first. So that's the blue equation that I'm solving. And then the green equation that I'm solving. So let me just remove this green color from here so that there is no confusion. When I solve simultaneously, I get two values. Check in equation 3. What is equation 3? Equation 3 is this one. I check over here. All three equations are satisfied. That means even though they did not ask for it, that's something extra. I just want my distinction. So that is, I have proven that the lines intersect, and this is like for distinction material kind of thing, like a 4-star thing. And then how do you find the point of intersection? Either place mu where it belongs. So lambda goes in line 1 or mu goes in line 2. So that is line 2 over here. And let me highlight the color. That is line 2. That is line 2. And that is how you find the position vector of point of intersection. Minus 1, minus 1, minus 1. Now it further says that the point A has position vector such and such. So the point A has position vector such and such. Show that A lies on L1. So this is OA. Plug it in over here in place of R.
you get three equations. One unknown, three equations, they all give the same value of A. That is the litmus test. It shows that point lies on line L1. Now the fourth one is my favorite. That is, the point B is the image of A after a reflection in the line L1. Now you have to draw a diagram. Line L1 and line L2 are perpendicular. That was stated earlier. This is the point of intersection. Let me call it M, which is -1, -1, -1. This is A over here. It says that A lies on L1. So A lies on L1. We want the reflection of A in this line. That is simple working of midpoint. That means the midpoint of A and B should be M. So M, position vector OM, is half OA plus OB, average. Apply this thing, we find OB as 3, -3, and 7. And that finally finishes this particular paper, which is May-June 2024, variant 31, all done and dusted. Stay tuned for more content on Mathematics with Shahab Yaqub.